The fifth term of an exponential sequence is 4375 and the second term is 35. Find the first term of the sequence. Now the first question that comes to your mind is, what does exponential sequence actually mean? Generally, I'm aware that a large number of people you are familiar with arithmetic progression and geometric progression. Now, for arithmetic progression, it's quite easy for one to decode. For example, if we have 2, 4, 6, 8, 10, and so on. Easily you can tell that this is arithmetic progression because the difference between the second term, difference between 4 and 2, is the same thing as difference between 6 and 4. So from here we can tell that the difference across the sequence is actually 2. So then we can say this is arithmetic progression. And for geometric progression, when the ratio of the second term to the first term, when it's the same as the ratio of the third term to the second term, then we know that that is actually a geometric progression. What do we mean by that? Take, for example, this kind of a sequence: 3, 3, 9, 27, and so on. Now, we know that the second term, when you do 9 divided by 3, it's the same thing as 27 divided by 3, and that will give you 3. So then we know that R equals to 3. So once this particular condition is satisfied, then we can tell that this is a GP and this is AP. Now, how do we now know exponential progression? Exponential sequence is, as the name implies, is any sequence that has each of the terms has the same base, but the power is different. The power might be increasing. What do I mean? Take, for example, when you have 5, 25, 125, and so on. Now, this kind of a sequence, of course, we know that you can express 25 as you have 5 squared, then 125 as 5 cubed. Obviously, you know the next term is going to be something like 5 raised to the power 4, which is 625. Now, when you have something like this, this is actually called exponential sequence. Now, for arithmetic progression, nth term in arithmetic progression is denoted as a plus n minus 1 bracket d, where a is the first term, n is the number of terms, and d is the common difference. Now, for geometric progression, this is for AP. For geometric progression, the nth term is AR n minus 1, where R is the common ratio. Now, for exponential sequence, we don't actually have like a general notation, but from this thing that I just explained, from this, we know that the basis will be the same. It's just that the power will be the different thing. So we can now say that the nth term of exponential sequence can be something like a raised to the power n, where a is the common base. So in this case, in this particular case now, a will be 5. But generally, a is not 5. It's not a universal value. But in this particular case, a is 5 and our n is the number of terms. So for second term now, that means n will be 2. So we have a raised to the power 2, depending on what our a is. So using this particular expression, then we can now solve this. We're told that the fifth term is 4375. So it means that T5 equals to 4375. 4375. And also the second term, T2, will be equals to 35. So these two were given. And from, let's call this equation 1. From equation 1, the fifth term will be, we have T5 will be equals to a raised to the power 5, and our T2 will be equals to a raised to the power of 2. So if T5 has been given to be 4375, so it implies that a raised to the power 5 will be equals to 4375, and a raised to the power 2 will be equals to 35. So let's divide these two, this particular term and this term. So we divide that, we have a raised to the power 5 divided by a raised to the power 2 will be equals to 4375 divided by 35. And this will in turn give us a raised to power 5 divided by a raised to power 2 will give us a raised to power 3, which is equals to this here 1. This will give you 125, equals to 125. So therefore, a equals to cube root of 125, which is equals to 5. So our a equals to 5. So that means the first term that we're looking for, so find the first term. First term is 5. Mind you, from this analogy I gave you, you observe that our base is the same thing as our first term. So once you get your first term, every other term will follow suit because it's an exponential sequence. So you know that for second term, it will be square of the first term. For third term, it will be cube of the first term. So that's why we can just conclude that a is 5. And mind you, this a that I used here is the same thing as your first term. So we can use this to represent the general term of exponential sequence. So that's just this. Our a is 5. So that means the answer is 5. So that'll be all for now. Thank you very much, and I'll see you in the next lesson.